and welcome to this webinar, Deploying and Testing Landing Zones at Scale. I'm Laurent Lesley, Azure Cloud Solution Architect.
Hello, my name is Nicolas Huen. I'm as well a Cloud Solution Architect working in the partner organization at Microsoft.
So today we are going to cover the following agenda. So talk about the Azure open source landing zones. We are going to focus more on the testing and how do you test infrastructure as code. Nicolas will go in a deep dive on how do you write unit test and integration test, and we are going to follow at the end on enterprise deployment. So how do you automate the deployment of the landing zone in your production environment? So what are you going to learn in this webinar? So first of all, we're going to talk about the benefits of using open source landing zone in an enterprise space. Do you write and run infrastructure testing? And how do you deploy public open source landing zone in a private environment? If you are interested about hearing more about our Azure solutions, you can also click on the Contact Me button and fill the form, and someone will contact you. So let's start about the Azure open source landing zone. So I want to start the discussion of the enterprise landing zone about talking about open source and open source in the enterprise space. So at Microsoft, we see more and more large organizations embracing open source on a daily basis. And open source is a very great way for our customer to be able to leverage what the others are doing on the open source community. So the Cloud Adoption Framework Terraform landing zones that we've been building now over 1 year across the different incubation cycles is based on this concept of leveraging an open source community. I want to start talking about this picture to give you the idea of what open source really bring when you start using it in the project. So this is the black hole picture that was published a year ago, and this is using open source libraries everywhere. So what is very interesting, and when you see those different names, it's just some public, open source repositories that the team have been using. But when you do some work on an open source project, so you've got the direct contributors, and on this black hole picture, it's very interesting to see that 200 plus people have been directly contributing about building this picture. But when you look at the number of people that have been involved in all the dependencies and all the libraries that I showed you before, this is more a wider community that the team has been able to use. So this concept of open source enterprise, and that's what we see with GitHub, Microsoft acquisition of GitHub, building and helping enterprise to really embrace this open source culture, is no single person of a team can make the progress that we can make together. And that's really with this approach that we want to bring you on the journey of the landing zone, to show you the benefit of leveraging enterprise grade landing zone that can be contributed by a lot of different customer, partners, people at Microsoft that you can leverage into your enterprise space. So we're going to go for a demonstration to show you, first of all, the Azure open source landing zone and how we do some testing on the GitHub Actions.
You can get access to the Azure Terraform landing zone by going to the ak.ms TF landing zones. You will be redirected to the GitHub project where we store all the public landing zones on the framework. If you scroll down, you can see an introduction of the framework, so how the framework has been built between landing zone and modules and blueprints, and scrolling down you got some samples landing zone. If you click on the landing zone hub and spoke, you can go into more details, and this is where you can see the reference architecture that we are using for that. So this is a traditional hub and spoke, and in this hub and spoke we've got different components, and here you can see the submodules. So if you're interested to understand how it's working, so just navigate, go through that, clone the repo, and you can get access to the different modules. So it's a good way to learn. So now if you go to the GitHub Actions, so this is where we are doing the testing. So those public landing zones are continuously tested. So someone is submitting a pull request, it's going to be executed to make sure that all together those landing zones are still working. So if you pick up one of those, so this is the integration test for the landing zone, you can see there's a workflow file, and in this workflow file, this is where we structure the different parameters. So you can see the different jobs. So this is the level 0, the foundation, when we store the Terraform state. The CAF foundation are the shared services where we put all the diagnostic the activity logs, and this is the landing zone themselves. So you can see we are using the matrix on line 120, and we test all the different permutations. So then different steps to execute the deployment and the destroy as well. So going down to the logs, so you can see all the different steps being executed. And in this one, if I expand the deploy landing zone, you can see the rover with the parameter files and all the context. And it's very good because here you can see the detail of the Terraform plan, and you can know exactly what the landing zone is going to deploy. So very good way to get visibility and evidence on what's going to be done by the landing zone on the framework. So feel free to explore those frameworks, those GitHub Actions log. It's a good way for you to learn as well.
Now we're going to have a look at testing applied to infrastructure as code and understand why it is important to test your infrastructure. So why is testing important? Testing is an essential part of software development lifecycle. It's here to reduce the risk by proactively finding issues, enforcing authority by watching code that can be tested, and prevent regression as well, and facilitate changes. So it's also a very good way to document code and features. And just like any piece of software, so it can be C#, Java, or Go, infrastructure as code must be tested. Testing is time consuming, but it's product saving. So broken infrastructure code will have devastating effect on your production. So if something is broken in your infra as code and that you go with that in production, it can delete everything that you have in production and break your entire environment. So it's critical to apply testing to infrastructure as code. So what should we test? We should be doing two things: unit testing and integration testing. So unit testing on the left-hand side is focused on single module or component, and the goal here is to assess the accuracy of the generated resources. It can be enforced during the plan stage and apply stages with Terraform, and here we want to leverage the Terraform JSON output to validate the naming conventions, the SKUs that are going to be deployed, the number of resources, or the tags. So we can really have a look at the metadata, have a look at what the plan is for Terraform, and assess if we want to go further before deploying things into the infrastructure. The unit test has a narrow scope, and we want to test simple things, so it should be easy and quick to test. On the other hand, the integration testing is here to test the full landing zone or a blueprint. We usually do the integration test after the apply stage, and we want to enforce here that all resources have been created, modified, or deleted according to the plan that we had in mind. The goal here is to validate metadata, resources status, and the end-to-end flow. So when we talk about end-to-end flow, it can be doing a call to a web request, testing an insert on the database, and testing that the entire logic from our application is working before we move on to the next stage. So let's have a look at the flow that we can put in place for testing. The first step is to prepare an empty environment so that we can deploy our test in a staging environment. We're going to design module or landing zone according to a plan that we agreed on with the architect team. Then we're going to write unit tests or integration tests. We're going then to write infrastructure according to the test plan that we put in place. And if the test fails, then we're going to refactor our code and run the test again until it's successful. At the end of the test, we want to make sure that beyond creating the resources, we can destroy the resources as well, and that we can return to a known state, and that the entire flow is working correct. Now we're going to see how we're going to write tests for infrastructure as code. So we're going to have a look at how to write unit tests, and then we're going to have a look at how to write integration tests. So we have a few tools that we recommend for this. First, we're going to use Terraform for our landing zone, so we're going to use Terraform as well for testing. And in Terraform, there's two key features that we want to use. The first one is Terraform show, using the JSON representation for TF state files, and the second one is Terraform output, again using the JSON file format. Here the goal of the output is to extract the values of our Terraform apply phase to get the information after the deployment. We're also going to use JQ. So JQ is a lightweight and flexible command line JSON processor. The goal here is to pre-process the output from Terraform, extract some key values to pass them down to the next stage. And the next stage is using the resource graph API to retrieve what has been deployed on Azure. And here the goal is to use the Azure SDK to query at scale using the language called KQL for QStore query language. Let's have a look at the unit testing strategy. Here the objective is to validate that the configuration of a single component, such as a module, is working as expected. The first part, we're going to use the Terraform plan before any deployment, and we want to validate here that the plan phase is successful. So we want to make sure that Terraform doesn't have any issues. Then we want to retrieve the Terraform plan state as a JSON file, and then we want to pass this JSON file using our preferred tool or language. It can be Golang with JQ, or it can be C# or Java, for instance. We're going then to extract the relevant metadata and compare them to the expected results. Let's have a look at some code. So here we have some Terraform files. We have some resource groups that are going to be created, and we have 3 resource groups. So we have an API demo, we have a networking demo, and we have inside demo, and we're using a prefix as well. On the right-hand side, we have our unit tests. The unit tests are using some key imports from Golang, so we're going to use GitHub Testify for the assertion phase, but we're also going to use the Terraform JSON SDK. And this one is fundamental because if you have a look at the code below, the Terraform SDK is going to call Terraform. So we're going to be able to call Terraform from our test, call the plan phase, get the output from in a JSON format, and then challenge this output based on a few assertions. So in my code, I have actually 4 assertions. I have counts, so I'm going to assert that there's 3 resources that have been created, and then there's the 3 resource groups. So I want to make sure that I have 3 resource groups that have been tested, and that the name is correct as well.
So Nicola, if I may ask you a question. So basically here on the left, you got a config file. This is the way you want to name your resources. And on the right, you are showing the code, and you want to make sure that, for example, if you specify that you need a prefix, the concatenation is going to be done as expected. Is that basically what you are doing in the unit test?
Exactly. So this is a unit test. So we are trying to test a single feature. Here we want to make sure that the plan phase has worked for our resource group module. And in our definition, we have 2 things, right? We have a list of resource groups, so we have 3 of them, and we have a prefix as well. And we're using behind the scene the CAF naming convention, and we want to challenge that the naming convention is working and that our resource group module is working as well. So we know the expected result of this configuration, right? We have the prefix, which is test, and then we have the resource groups. So the output of the Terraform plan should be 3 resource groups called test API demo, test networking demo, and the last one we test inside demo. If everything works to plan, then this is exactly what we should get in the Terraform output.
And you are assuming the test will be successful?
Yes, the test should be successful, and we'll do a demo afterwards to explain how this is done.
Very good. Let's talk about integration test.
So the integration testing strategy is a bit different here. We want to validate here that the deployment of a module and a broader landing zone is successful for a targeted environment. So we're not here unit testing features anymore. We want to have a look at the holistic view of what has been deployed in Azure, and we want to do that after the Terraform apply phase. So really here, we want to deploy our code, we want to test our code based on the environment, and we want to make sure that what has been deployed is actually what we had in mind. So here's the methodology. We're going to first validate that the apply phase is successful. So we're going to get the output from Terraform, transform that as a JSON, and we're going again to extract some metadata and compare them to the expected result. At the end, we're going to destroy the resources as well to make sure that the end-to-end process is working, that we can create resources, update them, and destroy them. Let's have a look at the technical side. On the left-hand side, we have the Terraform output. And the Terraform output, again, is configured by code. So we can choose to output some names, some IDs, some information about resources, such as the FQDN, the SKU of a VM, or public or private IP address. We're going then to use Terraform output with the JSON formats, put that in a file, and use JQ to extract some key values. In the example here, I want to extract the tags that are applied to a SQL Server instance. So the SQL Server has been deployed with Terraform. I know exactly the values that I expected because I've been writing the code for this deployment, and I know that the SQL Server is outputting some tags. So I can retrieve them again using JQ. This is going to be helpful afterwards to pass this output and challenge that with the next stage, which is the Resource Graph API. So what's the Resource Graph? It's a service that extends Azure Resource Management by providing efficient and performance resource exploration. If you've been using the portal, this is exactly what's happening when you do a search. So every time you do a search in the Azure portal, you do get some results, and it's using behind the scenes the Azure Resource Graph. The goal here is to provide efficient and performance resource exploration, and to be able to query complex resources, doing filterings, grouping, all type of search to aggregate multiple resources or filter resources. Here the goal is really to enforce governance, enforce that you know where your resources and how to query them. And the new features as well that we have in the resource graph is the ability to detect changes that has been made to resource properties. And this is really in line with the deployment that we want to do and the continuous process. So let's have a look at a resource graph query. So again, this is using KQL, so Custom Query Language, the exact same language that we have in Log Analytics and the Data Explorer as well. We're going to start with a table first. So here it's the resource, and then we're going to do some filtering. And finally, we want to project not all the information, but we want to do some advanced filtering. So we just want the ID, the name, and the properties. So the type here is a resource. It can be resource containers as well if I want to query resource groups. But here I just want to get information about the SQL Server. So I'm going to select the resource table. Filtering, again, I'm interested into 2 things. Interesting in a specific database that I've created. So I know it's going to be called Contoso SG. And I just want to get the ID, the name, properties and tags. I don't want any additional information because I'm not going to use them into my integration test. This is the output of the resource graph. So you can go to the portal, go to Azure Resource Graph Explorer, and start your query your resources. So start to get used with the language, play around, do some queries on your production environment or dev environment, and see what's the output and how you can leverage that into your integration testing. How do you use that? So we've been doing the query, that's great, we know what type of information we can do. Now we need to apply integration testing at scale. So here in this example, we're going to use Golang, we're going to use as well the Azure SDK in Golang, and we're going to use the output. So we are copying the output of Terraform that we had before using Terraform outputs and JQ. We're putting some of the values into our environment variables, and then we're getting these environment variables back into our unit tests. We then call a query using the Azure Resource Graph API, and we want to extract some key information using the API. So again, I can get the properties, I can filter out the properties, and I can challenge the properties using Golang unit test to make sure that the result is expected. So what's the result expected from this query? Again, I want to get the information from my SQL server. So I'm going to make sure that the SQL server is located in Southeast Asia, that is using the right version of the SQL engine, and it's targeted at the right environment as well, so that the tags are valid as well. Then I'm going to make sure that I only have one single resource, and at the end of the day, what I can do as well, if I want to go a bit further, is I can test manually the properties using unit tests and other assertion into my code, and going further and making sure that the integration test is fully compliant with the expectations.
Okay, this is great, Nicolas. So before we go to the demo, it's very good to remind for everybody in the audience that testing infrastructure as code is very similar to testing any software. So you got unit test. So you test during the planification phase. You want to check if something is working as expected, but you don't deploy. And integration test, you deploy the resources and then you compare with what has been deployed. So this is definitely the two approaches that we are taking to be able to test all the public landing zones.
Exactly, and what's quite important as well is that we don't go straight in production, right? We do some testing into multiple environments before we move on to the next stage, and this is what we're going to see now.
Let's have a look at our custom module. So this one is a very simple one. We're just looping through a list of resource groups and creating them on the fly. We're going to use 3 parameters, so the prefix, the name for every single resource group, and a list of tags, again, that are going to be passed down into parameters. So let's have a look at the variables. We have the list again of resource groups. So in the sample, we have 3 of them, the prefix and the tags. We also have here an example folder where we're going to have the locals defining some pre-baked variables and inputs, and we're going to use these to test our module. So let's have a look. Let's call Terraform with this resource group module. I'm going to go in the command line and do a Terraform init first. So this is downloading all the dependencies. Now I'm going to do a Terraform plan and output the file locally. I'm using the out option to select the file where I want the output to be. Okay, great. I have 3 resources that are going to be generated. So hopefully these are the 3 resource groups that I used into the local.tf file. Now let's use JSON format to be able to pass the output of the plan into our unit test. So this time we're going to use the Terraform show command. And again, putting into parameter the test.plan and outputting a test.json. So I now have 2 files. I have the test plan, which is a binary format, and I have the JSON file as well, which can be passed into our unit test. So I'm going to output this JSON file path into an environment variable. So I'm going to do an export JSON plan path, and I'm going to select the path to this specific file. I can now go into my unit test folder. So it's organized in test, then units, and into the unit folder, I have a single file, which is resource group module unit test. So this is the unit test file. We have 2 dependencies. The first one is Terraform JSON. So this is an SDK from Terraform. And the second one is the testify asset library. In my single unit test, I'm going first to read the JSON file using the environment variable that we've configured in the previous step. And then I'm going to read this file using tf plan. So I'm going to use the tf JSON library using the plan method, and then reading the file, mapping that to the file format from Terraform. I'm going then to have 4 sessions. So the first one is testing the number of resources that has been generated. And then I'm going to have 3 additional tests to test some metadata. I'm simply going to call GoTest, and I'm going to use an additional tool to generate the report using the JUnit format. Let's first go into our test folder. So I'm going to navigate to the unit test folder. I'm using GoTest with the verbose option, and I'm also going to use GoJUnit report to generate a JUnit report format file. I only have 1 unit test. The test is successful. I have 1 test, 0 failures. And I've been testing 4 things, as I mentioned before, so the number of resources, and then the metadata of our 3 resource groups. So now let's see what happens if I try to break the unit test. So I'm going to change the first test session. Instead of 3, I'm going to put 4. I'm going to save the file and run the test again. And here I do have a failure. So again, 1 test, 1 failure that I can easily repair. And that's a great way to make sure that the test is actually working as expected.
Right, so let's talk now about the enterprise deployment. So how do you automate the landing zone updates into your production environment? So we've seen the public open source landing zone on GitHub. So we show you how we are doing unit testing, integration tests using GitHub Actions. And now I'm going to show you how we are transitioning to a private repository. So in this example, you can see Azure DevOps, but it can be also a GitHub, a private project. It can be any Git repositories that you are using in your organization. But the idea on this private repository is to fork the public Azure landing zones, and this is where you host your private configuration, repositories, and pipelines. And from that repository, this is where you deploy your Azure resources. So when you fork your landing zone, so you will get like a copy. So the fork is a copy of the public landing zone. So meaning that you got a copy of the landing zone available. What you see here is a landing zone on application gateway. And the benefit of doing that is you've got a snapshot, a copy. So you know exactly which version you are going to deploy in your private environment. You've got also a configuration repository, which is an additional private Git repository, and this is where you are going to host all the configuration files of landing zone. So here you can see the demo landing zone for API management, and I can store my private convention. I can declare where do I want to deploy, in which regions do I want to deploy the landing zone, use a prefix, which version of the product. So it's becoming very specific to the landing zone, but this is where at least you can store that. What you see as well on the tree, you can see the demo environment, but you can also get another folder that you can call node production. This is where you can start mapping your environment in the way you want to tailor the deployment of the landing zone in your environment. So this is an example of the pipeline. So what you see here is all the steps connected together. And this is a destroy pipeline. So this is why if I go from left to right, so we can start with the application gateway. Then you can see here different components like SQL Server, API management. I got some networking. I got some release agents and my launchpad. And at the bottom, you can see the different repositories that have been used. So it's very good for traceability because when the pipeline executes, you can know which version of the configuration that you've been using and which version of the landing zone that you've been using as well for the deployment. And then when you execute the pipeline, you can see all the different checks. So what has been successful, where it's been failing. You can rerun stage if you want to, or you can narrow down into the different logs. And Nicolas showed you earlier the different testing scenarios, but you can augment as well the pipeline to include your own testing framework. So you can put some security testing, you can put some compliance testing, you can put some performance tests. So you can really tailor in your private environment in the way you want to leverage those public landing zones.
Exactly, yeah. We want to install the concept of gates, just like you're doing when you deploy a new version of your application. You should be doing the same thing when you deploy a new version of your infrastructure as code. So essentially testing every single stages, making sure that we do unit tests first, then we do integration tests to make sure that we can proceed to the next deployment, to the next landing zone, and to the next layer before we move on. And essentially doing some traceability, understanding what has changed, doing some logging as well, and validating our assumption, validating the environment before we temper anything in production.
I think, Nico, it's time for a demonstration. So can you tell us more a little bit?
Exactly. We're going to have a look into this demo about how to test your deployment and making sure that everything is valid before moving on to the next stage, essentially showing to Azure DevOps our deployment at scale of an enterprise landing zone.
Let's have a look at our enterprise deployment. Here we're deploying landing zones through automation with Azure DevOps and the pipelines. So we have a pipeline with 6 stages. The first stage is deploying the launchpad. The second one is creating release agents. And then we have 4 stages dedicated to our landing zone. So the first one is CAP Foundation. Second one is the networking part. And then we have 2 workloads, so our SQL Server and a web application, which is hosted on an Azure container instance. You can see that for every stage in our landing zone deployment, we have some tests. And these are integration tests that we are running at every stage to make sure that we can move on to the next section, because we do have dependencies between the foundation, the networking, the SQL, and the web stages. Let's focus on our SQL landing zone deployment. So we have multiple steps, and each step is running into our Rover container, which has Terraform and Golang installed. You can see as well that we have 2 repositories. The first one is CAP configuration, and the second one is our Terraform landing zone repository. So essentially, we're splitting the configuration and the pipeline in the first repository, and the actual Terraform landing zone code in the second repository. Now that we have the code for the 2 repositories, we can move on to the next section, which is the apply stage. In the apply stage, we're simply doing a Terraform apply with the code from the landing zone and the variables for our specific environment. Once the Terraform step is successful, we can then move on to our integration test that is going to challenge what has been deployed on Azure compared to our assumptions. The integration test here is using Golang, same concept as the unit test, but this time we're going to use another tool, which is the Resource Graph API. Once the integration test is completed, we're simply going to publish the results. And we'll be able to see which tests are successful and which tests fail. So let's have a look at the results from our integration test. I'm going to navigate back to the full deployment, and I'm going to select this time the results for the SQL test. So clicking here with our test results. For this deployment, we have a total of 4 tests. So 1 test for the networking, 2 tests for the CAP Foundation, and 1 test for our landing zone SQL. Essentially testing that SQL Server has been installed correctly, that the log analytics and the resource group for the operation is deployed as well, and that the networking is successful as well, so that the VNet address space is the right one. Let's now have a look at our 2 repositories. The first one, CAP configuration, contains the code for the pipeline and our input variables for Terraform. Into this cache configuration, I have 2 folders, demo and production. The goal here is to segregate the configuration and the pipeline for each environment. So we have the demo environment here, and into the demo environment, I have the code for my multiple landing zones. And again, we'll be focusing this time on the SQL deployment. I have 2 files. The first one is the pipeline, and the second one are the input variables for Terraform. Let's have a look at the pipeline. As you can see, this stage depends on the landing zone networking deployment. We have to make sure that we do have the networking before we can move on to the SQL part. All the steps are running into our Rover container, which contains all the required tools. And the container is running in a virtual machine in our subscription. We also have some variables that we're going to use within the deployment. And then we have multiple steps. So the first one is doing a login, and we're using MSI to prevent using your username and password or service principals. Then the next step is doing a Terraform apply and using again the output as a JSON for the TF stage file. And we can then extract some variables using JQ, so the same system that we've been using for our unit test. We're extracting values from the output of Terraform. Here we're getting the name for the SQL server, we're getting the name for the resource group, the environment, the SQL version, and the location. And we will need these variables for our integration test later on. Our integration test is focused here on running a Golang unit test. We're using the JUnit format as well, so we can export the results and see them into our pipeline. You can see on line 72 that I'm calling the Go test command line with the variables option and outputting the results into JUnit format again using the Go JUnit report tool. Let's now have a look at how the integration test is coded. I'm now going to move on to our second repository, which contains the code for our landing zone and the code for the integration test as well. In the Terraform landing zones repository, we have multiple landing zones. They're organized in 3 categories: blueprints, landing zones, and modules. The landing zones folder is separated into multiple deployments, and we're going to focus on the landing zone SQL. So here I have the code for the landing zone, which is simply calling the blueprint SQL Server module and deploying a SQL Server instance. And we have as well the test folder, which contains our integration tests. In this scenario, I simply want to test that our SQL Server has been successfully deployed and that the naming convention is matching what I have in the Terraform script. So here we've done 2 things. We've automated the deployment of landing zones through a pipeline, and we've tested as well that the deployment is a success by combining Terraform and the Azure Resource Graph API.
Thank you very much, Nicolas, for this great demonstration. I hope all the audience enjoy it as well. So in this webinar, we show you how to leverage the GitHub Enterprise Public Landing Zone, how it's been tested, and how you can benefit and get that working in your private environment.
Thank you, Laurent. So now it's time for the questions. We'll feel free to put any of the questions in the chat pod, and we'll get back to you shortly.